Hi. In a previous video, I just introduced you to my newest project, MDL, which is an optimizer for Z80 assembler code. So in this video, I want to continue talking to you about MDL. And the next thing I want to explain to you is what is the type of input that MDL can take. As I was starting to explain in the previous video, there's lots of different assemblers for Z80 code, right? Like, for example, here there's a few ones like SJASM, TNIASM, PASMO, GLASS, ASMSX. There's lots of them, right? And I'm missing many of them. So their syntax is kind of incompatible. Because things that you can write in one, you cannot write in the other, and even some expressions that are parsed by by two or more of these assemblers, they might be parsed in different ways, right? So the same exact line of code might result in different bytes in the binary, depending on which assembler you use. And I'll show you some examples of that later on. So since MDL is a single tool, I was trying to make it as independent as the underlying assembler that you use. So right now, it supports the following assemblers that you see in the screen, right? So it supports GLASS, it supports ASMSX, it supports SJASM, it supports TNIASM, PASMO, WinApe, and SDCC is a C compiler, but it generates assembler code as output that then is assembled into a binary. So the output of SDCC is also supported by MDL, right? So, but you have to tell MDL which assembler are you going to use, because otherwise just the syntax is ambiguous, right? So let me just show you how to do that. All right, so here I have a text editor and a terminal to run MDL. So let's just write a little test program. So for example, I'm going to say load 1 into A, and then I'm just going to create a loop to terminate the program, right? So this is a very stupid assembler program, but just to get started, right? So I'm gonna try to optimize it with MDL. So I'm just gonna say Java jar. I have MDL right here. Test.asm. I'm gonna call the optimizer, and I want to save the result as test.mdl.asm, right? So it says it found one optimization and one pattern was applied. So let's see how did it look. So I have here, how do I call it? Test.mdl.asm. So I have it right here. So this is the result of optimization. So it just removed this load a,1 that wasn't used, right? So this worked fine, but let's say if I add some dialect specific things. So for example, ASMSX allows you to add this directive here, .rom, which defines the header for an MSX ROM cartridge, right? So if I try to now compile this, it's going to complain that it does not know how to expand this macro, right? So it basically fails to parse. So if I want to be able to parse this program is a valid program in ASMSX. So I just have to tell MDL which dialect am I using. So I can just say dash dialect, and I say I'm using ASMSX, right? And now it doesn't complain. Now it actually finds the optimization, and if I look at the output, it has replaced this ROM thing by the actual header. It has optimized the load a,1, and ASMSX has the funny thing that when you define a ROM, it always fills up the ROM all the way up to the nearest 8 kilobytes with zeros. So MDL has inserted this just to be compatible with ASMSX, right? So that if you compile this, it generates exactly the ROM that would be generated by ASMSX if you compile this, except with the optimization removed, right? All right, so that's one example. Now let's see. Another thing that other dialects support is, for example, let me just do, I don't know, I'm gonna load some value into HL, whatever, and then I'm going to say LDA HL++. And you would say, what is this crazy syntax? This is not even assembler. Like, we're sure this is actually not proper Z80 assembler, but there's some assemblers that support that. In particular, SJASM supports this, and this means to load into A the value of the memory pointed by HL, and then increment HL, right? So that's what SJASM supports. So if I try to compile this, to optimize this with MDL, of course it's going to fail, right? Because it doesn't know what this ++ here is. But if I just say we're using SJASM, then it actually reads it properly. It detects that there is actually an unused instruction and removes it, and the output of the optimized program is this, right? So we load this value into HL. Then we were loading into A the value of HL, but that was never used, so that is removed. And really, these two instructions are never used, so they should also be removed. But as I will explain in the next video, the optimizer used by MDL is still not perfect. I'm still working on it. So it doesn't fully do all the optimizations that should be done, right? But these two should be fairly easy to detect. And after recording this video, I'm actually going to fix it to be able to remove these optimizations, because I just realized this should have happened. But anyway, so this is how you specify which dialect which assembler dialect you use in your input program. And you can specify, as I was saying, any of a collection of supported dialects that MDL accepts as input. And as I was saying, MDL currently supports this 7 dialects: GLASS, AS-NSX, SJASM, TNI-ASM, PASMO, WinApe, and SDCC output, right? So you can specify which one of these you are using with the -dialect flag. And just to complete this, this second MDL video, I just wanted to show you one additional feature that MDL has. So you can write assembler code in many different ways, and assembler syntax is sometimes dangerous, right? There's lots of ways in which you can write statements that, depending on which assembler you use, will be compiled in a different way, right? They would generate different bytes in the binary. To try to prevent that, in case someone else uses your code but with a different assembler and they're having troubles, or you are trying to use someone else's code and maybe they wrote it for TNI-ASM and you are using GLASS, for example, right? MDL can generate code style warnings that try to prevent that, right? And I'm just going to show you a few examples. Okay, so I have here again a text editor and the command line to run MDL, and I just wanted to show you some examples of dangerous or ambiguous syntax in assembler. Before I show you these examples, I just wanted to clarify, by no means I want to force people to code in one way or another, right? So everyone writes assembler however you want. I just want to point out some of the dangers of using certain types of syntax, right? And these dangers are more apparent if you are going to share your code, or if you are trying to use code from someone else, right? If, let's say, you are writing your own assembler game, maybe you don't want to share your code, but you download code from someone else. And let's say that you are using one assembler, let's say you are using GLASS, and someone else, the code that you are using from, maybe that person used TNI-ASM, right? So you bring the code into your code base and it compiles, right? And you think that is fine. But just because it compiles, that doesn't mean that it's safe. Depending on what syntax you use, the output that you're going to get might be different, right? And I just want to show you some examples, but there's many others. Like I'm going to show you a few examples involving escaping sequences, labels, macros, but there's a few other examples, like, for example, local labels that are interpreted different in different languages, in different assemblers as well, that I'm not going to have time to show you. But let me just start. Let me show you what I mean. So let's start with a very innocent line. Let's say I'm going to have a label called foo, and I'm going to put an instruction, assembly instruction. Let's say not, like the no instruction, right? And the only thing I'm going to tell MDL to do, I'm not even going to ask MDL to run the optimizer. So I'm just going to say java jar MDL test and I'm not going to run the optimizer. To run the optimizer, I have to do PO, but I'm not going to do that. I'm just going to say read this assembler interpret it, and then just save the output as, let's say, test mdl.sa. So I do that, and after reading this, MDL just reads this and then generates assembler. In this case, since there's no optimization, it should output exactly the same thing, right? So this is the way MDL interpreted this code. So now let me do something very innocent. I'm just going to delete this column, right? And lots of people use labels without colons, and lots of assemblers actually encourage writing labels without colons. And that is actually not a problem most of the time, right? So MDL can read it, can interpret it fine. In the output of MDL, it always puts the colon. With a command flag, you can ask it to remove it, but it has interpreted fine. But let me just show you why this is dangerous. So imagine that this file had some include statement, right? It had included something, and that include had, for example, something like this. And I'm going to make this up as I type, but I hope you get the point, right? And macro, right? So now, if I ask MDL to interpret this, it interpreted fine, but now look at what happened. So the output has two knobs and no label whatsoever, right? So what has happened? What has happened is that this foo, instead of seeing it as a label, it has seen it as a macro call with argument knob. And this macro gets an argument and just repeats it twice, right? However, if I would have put the column there, then MDL would have actually complained, because clearly you cannot have, you define the label twice, right? So I don't know if you see the problem here, but notice that this line, without changing anything at all, right? If we have this before, it expands to this. But if I remove this without changing the line, I'm not changing the line, now it is interpreted as a label, right? So when you define a label without a colon, you don't know exactly what the assembler is going to do. And some assemblers are going to take it as a label, some assemblers are going to take it as a macro expansion, right? So defining labels without colons can lead to ambiguous syntax. Again, it's up to you to write the code however you want. But I just want to point out that that's a danger, right? So especially if you want to share code, because this problem arises mostly if you share your code with someone else, right? That uses maybe a different assembler. So if you want MDL to warn you when this happens, right? To warn you when you're writing something that can be dangerous, you can just add the -warn flag. And in this case, it's going to say, warning, there's a label defined without a colon, right? So it's going to warn you. And if I put the colon, then it's not going to complain anymore, right? So this is one example. Another example is, let's say that I say ld load a,1, and then I just want to subtract, I don't know, 2 from a, right? So this is fine, but some people don't like the way this subtraction operation is written in Z80 assembler, because when you add something to a, you write it like this, but when you subtract, you actually do not write a. So this is weird, right? Some people like writing it like this. And this is fine. Some assemblers take it, right? So if I process this with MDL, it's going to interpret this fine, right? It removed this because MDL always generates official output. But not all assemblers support this unofficial syntax, right? So if you want to make sure that you are not using any unofficial syntax, you can again put the warn, and MDL is going to warn you, right? You use unofficial syntax in line 5, which is this, right? This is another example. And then one final example of something that is dangerous is SGSM allows you to define temporary labels, right? So you can define a label with a number, and then you can just say jump to the nearest reusable label that is before, right? So when you put a 1 and a b, that means look for a 1 before. So if I have these two labels, the 1b refers to the one before, not to the one after, right? And this will be compiled fine. So this is actually interpreted fine. MDL, of course, renames those labels, and it knows that this one refers to this one. However, this is dangerous, right? Because what if I have some code here, right? And then I have another code there with another reusable label 1. And for some reason, I'm optimizing and refactoring my code, and by pure chance, I just remove this, right? Because it's not useful anymore. So the compiler is not going to give me any error because this label still exists. But now it's going to jump here, which is not where I wanted it to jump, right? So these reusable labels are useful, but they're a dangerous idea. So if you use them, please be careful because they can lead to these weird situations that you just comment out a line, the compiler doesn't complain, but now your program doesn't work, and you don't know why, right? So again, if you say -warn MDL, oops. MDL should have warned you. I just found a bug while recording this video. This should have resulted in a warning because you're actually using these reusable labels, right? But anyway, so this is some examples. Oh no, there's one more example I wanted to show, and this one is one of my favorites. This is something that I just discovered last week that it happens. So imagine that you have a very, very innocent line, right? I have this hello \n, right? And I compile this. Let's say I compile it with glass, right? Oh, I didn't save. Sorry. I compile it with glass, also with the dialect of glass. So glass is going to interpret it like this. It's going to this hello, and then there is 10, which is this new line character, right? There's a 10 here. However, if you were to compile this with TNI ASM, and I've checked this with the original assemblers, right? I'm not right now using MDL, but MDL is mimicking the behavior of the original assemblers. So the same exact line, but TNI ASM is gonna interpret it as hello, a \, and an n, because TNI ASM does not escape the characters in strings, whereas glass does. And glass, for example, supports some escape sequences, and SJASM supports a different set of escape sequences, right, that you can find in the documentations. So I found this because I was trying to compile this project called Z80 Rogue, and Z80 Rogue has this this string that actually draws a picture, right? This ASCII art that is like, you know, like some drawings like this, right? And when I was trying to compile this with glass, this line was not compiling, because this line actually does not compile in glass, right? Because here you are escaping this double quote. But this compiles in TNI ASM because these are not considered escape characters, right? So my recommendation here is, if you're going to use escape characters, make sure that you are not going to switch which assembler you use, because they're going to be interpreted differently, right? So if you are writing code that you are going to share in the internet and some other people might use in different assemblers, instead of hello \n, please write it like this, which any assembler is going to compile exactly in the same way, right? So you are sure that your code can be reused by other people, even if they use different assemblers, right? And again, this is just my recommendations after having looked at all of these different assemblers. Of course, everyone writes the code however they want, and probably if you have written your own assembler, if you're one of the authors of, let's say, Glass, SJASM, and Plasmo, or whatever, you might be getting angry at me because you put so much effort into writing all of these features in your assembler, and I'm now telling people not to use them. But I'm just saying this in case people want to you write assembler code that can be used by other people that might use different assemblers, right? By all means, if you know you want to use one assembler and you want to use all the features, by all means use them, right? Like the creators of those assemblers put a lot of work into coding all of those features. But I just wanted you to be aware of the dangers, right? Especially if you share your code online and someone else actually wants to use it using a different assembler. All right, so that's all the examples I wanted to show. All right, so I hope you found that interesting. Again, I hope no one gets offended by me giving this recommendations that are totally my personal opinion, and you might disagree completely, and totally respect that. But I just wanted to say that because while coding MDL, I just found out all of those incompatibilities between assemblers that actually surprised me, right? I mean, I was aware that different assemblers have different syntax, but I didn't think that the same exact line could be assembled differently by different assemblers, right? The same exact line would generate different bytes in a binary, right? And I think that is the dangerous part. So that is why I wanted to generate some warnings in MDL, just to make sure that you are aware that the particular line you are writing might be interpreted differently in different assemblers, right? So anyway, as I was saying, so MDL supports a collection of dialects. Right now, these ones that you see in the screen, Class, ASMSX, SJASM, TNI, ASM, PASMO, WinApe, and SDCC output. You can select which syntax you want to use with the dash dialect flag to the command line arguments of MDL. And anyway, so I hope you found that useful. This video has been longer than I thought. I hope you found it interesting. It's just a bunch of things I learned while coding MDL. And then what is left for me to explain, which I think is probably the most interesting video, is how does MDL actually work? How does it actually optimize code, and how does it ensure that the optimizations are correct? And I'm going to explain that in the next video. So anyway, so I hope you found this interesting. Yeah, thanks for listening or for watching.